Welcome back, students. Now we're going to get into dividing polynomials using long division. So if you haven't checked it out yet, please make sure that you are familiar with long division with numbers because it's pretty much the exact same process. So what you're going to do first is we have this trinomial, x squared minus 2x minus 15. We're going to write it underneath our division bar. Now, always make sure that as you're writing it, that you have all of your terms, and if you're ever missing anything, that you put in a placeholder of 0. So notice how this goes x squared, x to the first, and then our constant. We're not missing any terms, so we're good to go there. And then we're dividing that by x minus 5, so that's going to go out here on the outside. And so what we really need to do is just focus in on the first term of each of our polynomials. Okay, because everything else is going to all be dependent off of these first terms. So we need to ask ourselves, x times what gives us x squared? Okay, so x times what gives us x squared? And that's just going to be x. So I'm going to place x down, and I'm going to multiply now x times x, which gives me x squared. Okay, but this is a binomial. If I want to, I can put parentheses around this. If I'm multiplying by x, I can't just multiply the first term, I also have to distribute. So I'm going to also multiply x times negative 5, and that's going to give me negative 5x. All right, now when you compare what we're doing right now to long division, after you figure out this number out here times what gives you this as close as possible without going over, that goes up here, then you multiply, and then the next thing is you look to see how far apart are they, what's the remainder, so you subtract. So we're going to do the same thing, we're going to subtract. So I'm going to take x squared minus x squared, but since I have two terms, I'm going to have to subtract both terms. So I'm going to subtract here, but minus and negative is actually going to change to a positive. All right, so x squared minus x squared, that cancels out, okay, because I was able to figure out x times what gives me x squared. Okay, but here I need to figure out what's my difference. So negative 2x minus negative already changed to a plus, so negative 2x plus 5x is going to give me positive 3x. And then we bring down the next term, which is a negative 15. And once again, we focus now on the first terms. So x times what is going to give me this 3x. So x times what's going to give me that 3x, and it's going to be a positive 3. So up top, I'm going to put a plus 3. And notice that as I'm figuring out what I'm going to be multiplying by, since it was x to the first, I placed it over the x to the first term. Since this was a 3, I'm placing it over the constant term. And this is telling me that I'm on pretty much my last step right here. I'm not going to do this process again. I might need to do something else, but not continuing the same process. So now I'm going to multiply 3 times x, which gives me the 3x. And then I'm going to take 3 times negative 5, which is going to give me negative 15. And then again, we subtract and we subtract. And 3x minus 3x cancels out. And once again, a minus and negative is going to change to a plus. And now I have negative 15 plus 15, which is 0. So this is my remainder. My remainder of 0 tells me that I can take x minus 5 times x plus 3 and get x squared minus 2x minus 15. Okay, if you want to do that off to the side, you actually could. So x minus 5 times x plus 3. I'd have to take x and multiply that by x plus 3. I'd have to take negative 5 and multiply that by x plus 3. And that would give me x squared plus 3x, and then minus 5x, and then minus 15. This gives me x squared. Combining my middle terms gives me minus 2x, and then minus 15. So because my remainder was 0, okay, it meant that this gave me this binomial that multiplied by this binomial gave me my original dividend, which tells me, because the remainder was 0, that this problem could have been solved by factoring, could have been simplified by factoring, which if you watch the first video, I think I changed from y's to x's, but it was the warm-up problem that we did by factoring. Okay, just a new method. But sometimes we're not always going to have that remainder of 0, which means it wouldn't have been factorable, and that would have meant that long division would have been necessary. So let's take a look at another example. Here I have x to the third minus 8x squared plus 4x minus 9. And I am dividing that by x minus 4. So I need to pay attention to really the first terms. So I have x and I have x to the third. So x times what's going to give me x to the third? And that is x squared. So I'm going to place x squared. It doesn't really matter where I place it, but it's helpful if you place it above the same term, the like term that it's going to be with, to kind of give you a hint as to how much longer you have to go through this process of long division and when you're ready to be finished with it. So x squared, and remember, this is a binomial, it goes together. So now I'm to the point where I multiply. So x squared times x is going to give me x to the third. And then x squared times negative 4 is going to give me negative 4x squared. And then I subtract. And I subtract. So x to the third minus x to the third means I have 0x to the thirds left. And now I'll change from a double negative to a positive. And negative 8x squared plus 4x squared is going to give me negative 4x squared. And then I'll bring down my next term, which is positive 4x. And then I ask myself, x times what gives me negative 4x squared? Well, this clearly has a coefficient of 1, and this has a coefficient of negative 4, so I'm going to need to have the coefficient of negative 4. And then x times what gives me x squared, and that's x. So now I'm going to multiply by negative 4x. So negative 4x times this binomial. Negative 4x times x is going to give me negative 4x squared. And then negative 4x times negative 4 is going to give me positive 16x. Okay, and then I subtract. So double negative, change to positive, and the negative 4x squared plus 4x squared cancels each other out. And then 4x minus a positive 16x, so 4 minus 16 is going to give me negative 12x. And then I'll bring down my next term, which is negative 9. And since I only have a spot for one more, I know that I'm on my last step here when it comes to this long division process. So I ask myself, x times what is going to give me negative 12x? Well, this has a coefficient of 1, and this term has a coefficient of negative 12, so it's going to be negative 12. And then x times what gives me x? Well, they're already the same. So I'm just needing to multiply by negative 12. So negative 12 times x is going to give me negative 12x. Negative 12 times negative 4 is going to give me positive 48. And I'm going to subtract and subtract. Double negative, change to positive. Negative 12x plus 12x eliminates. And then negative 9 minus 48 is going to give me negative 57. Okay, so right here, I've run out of anything to bring down. And also as an indicator that I was finished with this is the fact that I ran out of room for what I was going to be multiplying by next. So that means that this, what's left over, this is the remainder. So the way that we write our remainder is going to be our remainder over what we were dividing by. Okay. Once again, we could check, okay, just the same way that we checked with this one. It's just after we multiply this together, so multiply this trinomial times this binomial, then we would have to add in our remainder, and then that should get us exactly to what this original dividend was. So I think I will have another video for you to check out if you'd like to see that for checking to see if your answer works. But for now, I'm going to go ahead and move on to the next example. All right, so this next example, I'm writing down 4y to the fourth. And as I'm getting ready to write the next term, I recognize the fact that y to the fourth, the next term should be y to the third, and this one doesn't have that. So I'm missing a term, so I need to make sure that I put in a placeholder. So that means I'm going to put in 0y to the third. And then I'm going to put in my minus 5y squared. And then I have my plus 2y, and then my positive 4. So always a good idea to double check. So y to the fourth, y to the third, y to the second, y to the first, and then y to the 0, or just our constant. And we are dividing this by 2y minus 1. So it might not look like a division problem, but remember that negative exponent takes the base, moves it to the opposite part of the fraction. So this is still just a long division problem. So I'm going to go through and I'm going to ask myself 2y times what gives me 4y to the fourth? Well, I know it's going to be 2 times 2 is what gives me 4. But this is y to the first. I need y to the fourth, which means I need to multiply by y to the third. So 2y to the third. So 2 times 2 gives me 4. And then y to the third times y to the first is y to the fourth. And then I need to distribute. So I need to multiply this by the binomial. So 2 times negative 1 is negative 2, and then that'll be y to the third. And subtract and subtract. And my y to the fourths cancel each other out. But here I'll have a double negative, which will change to a positive, and 0y to the third plus 2y to the third is 2y to the third. And I'll bring down the next term, which is negative 5y squared. And then I ask myself, 2y times what gives me 2y to the third? Well, the 2's already match, but this is y to the first, and I need y to the third. So that means that I need to multiply by positive y to the second power. And again, if you get these lined up, looking to see what comes next is kind of an indicator for what term, what variable, and what exponent you're going to be multiplying by. So y to the second times 2y is going to be 2y to the third. And then y to the second times negative 1 is negative 1y to the second. And I'll subtract and I'll subtract. So the 2y to the thirds cancel each other out. A double negative will change to a plus. And negative 5 plus 1 is going to give me negative 4y squared. And then I'll bring down the positive 2y. And then I ask myself, 2y times what gives me negative 4y squared? And that is going to be negative 2. And then this is y to the first. I need y to the second, so that's going to be negative 2y. So negative 2y times positive 2y is negative 4y to the second. Negative 2y times negative 1 is going to be positive 2y. And I subtract and I subtract. And a double negative will change to a plus, and the negative 4y squared plus 4y squared eliminates. And actually, in this case, the 2y minus 2a eliminates as well. So this gives me 0y. And if I bring down my positive 4, I ask myself 2y times what gives me 0y, and that's going to be a 0. So I can put a 0 here if I would like. And then I can go through and I can multiply. But this right here, this is really termed, I don't really need that. 0y is just 0. This right here actually ends up being my remainder. All right, so then I'm going to plus my remainder, which was a positive 4, over what I was dividing by, which was the 2y minus 1. And again, we can check this answer in another video to make sure that we come up with the original dividend. Let's do one more example. Okay, so here we have x to the fourth and plus x squared. So I noticed that I don't have an x to the third, so I need a placeholder of 0x to the third, and then plus 1x squared, and then minus 3x, and then plus 5. And we are dividing this by x squared plus 2. But just like if the dividend doesn't have a term, so if it's missing a term, same with this one, what we're dividing by. If that does not have a term and we're missing it, we need a placeholder. So because this goes x squared and then a 2, I need to put in a 0x and then a plus 2. All right, so this one's a little bit different because now we're dividing by a trinomial. But honestly, the process doesn't change at all. It just means that when we go through and we multiply, instead of just distributing it to the 2 terms, we're going to distribute that to the 3 terms. So let's see how this works. So x squared times what gives me x to the fourth? And that's actually going to be x squared. So x squared times x squared gives me x to the fourth. X squared times 0x is going to give me 0 and then x to the third. And then x squared times 2 is going to give me positive 2x squared. And I subtract all the way through. And the x to the fourths cancel. It turns out that my x to the thirds eliminate as well. Sometimes that'll be the case, sometimes it won't be. And then x squared minus 2x squared, that's a 1 minus a 2, which is going to give me a negative 1 x squared. And then I'll bring down the minus 3x. And now the question is x squared times what is going to give me negative 1x squared? Okay, and that's actually going to be a negative 1. Okay, so negative 1 times x squared is going to give me negative 1x squared. Negative 1 times 0x is going to give me a 0x. Put a plus or a negative there, it doesn't matter. And then negative 1 times positive 2 is going to give me a negative 2. And then I'm going to subtract, I'm going to subtract, and I'm going to subtract. So double negatives will change to plus, and negative 1x squared plus 1x squared will eliminate. Negative 3x minus 0x is going to give me a negative 3x. And then I also have this double negative here, which will change to a plus. I don't have anything, so I also need to bring down the positive 5. And so that means I need to take 5 plus 2, which is going to give me positive 7. Okay, so this was my last term. That means that this right here, what remains, because x squared times something is going to give me negative 3x, that's not possible. All right, so that means that this, what I'm left with, is my remainder. So I need to plus and put my remainder, which is negative 3x plus 7, over what I was dividing by, which was x squared plus 2. So all of this would be my final answer. All right, and that is your process for long division.